In problem 9, we have a nozzle that's on the end of a water hose. And as you adjust the nozzle, you're basically changing the area through, you're making the area smaller or larger that the water gets to flow through. And as you make it smaller, the water has to go faster because the same amount of water is flowing through the hose, whether you've got that nozzle all the way open or partially closed. All right. So we know how fast the water is flowing in the hose. We know the cross-sectional area in the hose. And so the flow rate in the hose is the area in the hose times the velocity in the hose. All right, and so we've got that. We've got the area in the hose, that's what, 2.22 square centimeters. We've got the velocity in the hose, 1.97 meters per second. And we've got a nozzle that constricts the area down to 0.54 centimeters squared, right? So we've got a hose, 2.22 square centimeters. Oh, I wrote that a little too high, pardon me. Just come down here. We have a hose, 2.22 square centimeters. We have the velocity in the hose. That's 1.97 meters per second. And we have the area in the nozzle, which is 0.54. I wrote over it, so it's a little hard to see. 0.54 square centimeters. And the flow rate out of the nozzle has to be the same as the flow rate in the hose because water is not disappearing from anywhere. It's still there. So area of the nozzle equals times, pardon me, velocity in the nozzle has to be the same as area in the hose times velocity in the hose. All good, yes? So we've just got to solve for what we're after. We need the velocity in the nozzle. What is that? Velocity in the nozzle then is just going to be area in the hose divided by area in the nozzle times the velocity in the hose. There you go. That's the equation we have to do in Excel. So let's head to Excel. What do we have? We have VHOSE. Yeah, VHOS, yes. VHOSE is going to be 1.97 meters per second. A hose is going to be 2.22 square meter. A nozzle is 0.554 square centimeters, sorry. And so then the velocity in the nozzle is just area in the hose divided by area in the nozzle times the velocity in the hose. And that gets us to 8.1 meters per second coming out of the nozzle. We've increased the velocity by roughly a factor of 4. And that's it for problem 9.